Well, well, hello, physical science students, and welcome back to science. Today's topic is thermal energy transfers, and at the end I have your next assignment for you, so pay close attention. The assignment is going to be finding examples of some of the things we go over, so you'll really want to pay attention there. We'll get to that at the end. In previous assignments, a number of you, I've been really impressed, have pointed out how thermal energy can transfer from an object at a high temperature to an object at a low temperature. Many of you described this process where if the two things are next to each other, the faster moving particles in the high temperature object will be kind of bumping into the particles in the lower temperature object. And that will lead to a transfer, because high speed bumping into low speed, or high kinetic energy particles bumping into lower kinetic energy particles, there will be a transfer. And in fact, that transfer will continue until the particles in both objects have the same average kinetic energy. Now, you'll notice it says net thermal transfer energy has ceased. That's just emphasizing, this is worth pointing out, there are going to be some particles moving faster on this side that transfer their energy over to this side. But there are also going to be some that transfer their energy from this side over to this side. When it says the net transfer has ceased, it's saying that the overall is staying basically the same. So 2 units might go that way, but 2 units are coming this way. It's a wash. Now, this type of transfer, when the two objects are in direct contact, is actually the first of our 3 big types of transfer that we're going to cover here today. And it's a word we've seen before. It's conduction. Conduction in the electricity unit was conducting a charge by touch, while here it's transferring thermal energy by touch or by direct contact. It doesn't have to be between solids. It can be you in Lake Superior. You are definitely transferring thermal energy to Lake Superior, as it is at a much lower temperature. It's worth pointing out it has a whole lot more thermal energy. Heat transfers from higher temperatures to lower temperatures. So that's by direct contact. There are tons of examples of this, and I don't want to give them away because your assignment is going to be finding examples of all of these. But this one really should be the easiest. 2 objects in direct contact, thermal energy at different temperatures, thermal energy transfers. Second one is a little bit more confusing. It's called convection. Convection deals with fluid currents. Now, before I even get going, the fair question is, what's a fluid? Well, fluids include liquids and gases. A simple definition for it is fluids are things that can flow. So what makes this different than you being in Lake Superior is we're saying that when you have a fluid, if energy is being added in one part of that fluid, it can transfer throughout the entire body. As an example, a pot of water. If you put a pot of water on the stove, turn on the stove, you're adding energy at the bottom. Somehow that thermal energy gets transferred throughout the entire pot of water. Now you'd say, hey, isn't that conduction? It's actually a little bit more than just that, because it's not just the particles on the bottom stay on the bottom and they start shaking the ones next to it and it transfers through conduction. It ends up being that those particles on the bottom, as they warm up, they expand. When they expand, they become slightly less dense. Lower density objects float, so you end up with things that are called convective currents. This will be a little bit trickier to find examples of, but there are plenty of them. I'm quite confident you'll be able to come up with some. Remember, these happen in both gases, so air, as well as in liquids. The final one is the roughest, and I'll admit I don't even like my definition, I guess. I don't like how I state this. It's a transfer through radiant energy waves. The biggest thing to note about this is that this is the only form of thermal energy transfer that does not actually require matter. That's very important. It really is very important. The best example I can give you for this one, if you've ever seen or have a fireplace going where there's a glass barrier between you and the fire. You're not touching the coals of the fire, but you can certainly feel the effect of it, even without being above it, being up in the chimney. You can feel that flame. I used to have a nice gas stove in a basement and a couch very near it, and I would take a nap. I would study. I'd be deep studying the insides of my eyelids on that couch, and my dog would walk in between me and the fireplace. Even with my eyes closed, I could feel that, because all of a sudden, the thermal energy, hey man, where'd that nice radiant energy go? Dog is absorbing it. Chewy, get out of the way, is what I'd tell him. He'd lay down, and we'd both be happy. You may have experienced this at campfires or with a fireplace. You can feel when somebody walks in between you and that radiant energy source. So a very classic picture. A campfire pot of water above a campfire stove actually can represent all, again, above a campfire, can represent all three forms. We have conduction. As the metal heats up, it'll start traveling up through that handle if it's a metal handle. I suppose technically it would be traveling up through a wooden handle as well, just not as efficiently. It'll travel up through there, which is why if it's a metal handle, you need to be real careful. Use pot holders to hold on to it. This is also why many times pots and pans are made with plastic or metal handles, something that can resist that transfer through conduction. We have convection taking place within the liquid here. The water on the bottom is being heated up. Thermal energy is being transferred to it. Therefore, its temperature is increasing. And then you end up with these convective currents in through that pot of water. As the warm fluid rises, as the warm water rises, cooler water is going to come down to sink, and you end up with a great example of convective currents in there. And then radiation, we already mentioned, even without touching the campfire, even without putting your hand above it to feel the to feel the convective currents, you can feel that radiant energy coming off of the fire. To be real clear, everything in the universe that is above 0 Kelvin, which is everything, emits radiant energy. The amount it emits is based on its temperature. So the higher the temperature of the object, the more thermal energy it emits. It's in the form of infrared waves. So this brings us to our assignment. I'm going to ask you to find some common examples of these transfers, preferably ones from your direct experience. I'd like you to find at least 2 for each category. Again, the 2 for conduction are going to be pretty straightforward. 2 for convection, you can do it, you can do it. 2 for radiation will probably be the toughest. Again, you can do this. Give it a shot, that's all I'm asking. When you do these, do your best. Be sure to explain them. Don't just give me 2 words. Don't say campfire and expect that to be complete. Feel free to take pictures. Heck, use Flipgrid. I think this is one of it. This could be a good use for Flipgrid. I'll put this one into the all classes Flipgrid so that we can see how other people answer. Have fun with this. I want to point out again that you need to explain, because this item right here could be used for any of the 3 transfer methods. You need to explain these well. In fact, you're welcome to use this one if you want, if you know what this thing is. The name kind of gives away one of them. As far as hints, if you're having trouble with this one, I don't really want to give away anything here, but if you're having trouble, maybe go outside, get some fresh air, and sit in the sun for a little while. Maybe take a sauna. That might jar something loose. Or head to the kitchen and do some baking. Take a look in the refrigerator. It'll even help if you do that when you're barefoot. Just whatever you do, don't touch the stove. At least when it's turned on. With your bare hand anyway. Feel free to use any of these hints. Are those hints? Feel free to use any of them. Feel free to come up with better examples. Feel free to elaborate. Have fun. Please have this assignment finished before you watch the follow-up to this. I'm going to give you 2 days before I post the follow-up. The follow-up will be posted on Friday. I may even push it to Monday. In the meantime, there will be another assignment posted as well. So your 2 assignments for the week are going to be posted. Work on them at your leisure. Have fun. Stay safe. Keep sciencing.